So before we move forward, I just want to quickly talk about a couple of things. Some students, they contact me and they say, Gustavo, we are talking about raycasting, but I read somewhere that there is this thing called ray tracing, right? Are they the same thing? Are they different? Are we going to learn raycasting or ray tracing in our course? So I think it's important for me to just open a quick parenthesis and clarify what these two things are, right? These are two different techniques. So let me just look at raycasting first, ray tracing later, and then we can look at the differences and what are the main motivations behind each one of them. So if we talk about ray casting, right, the first one, this is probably the end result that we're looking for, right? And in the ray casting technique, the rays, they are cast and traced in groups, right? So what does that mean? That means that if we get an example resolution, right? So let's just say that we have a screen that is 320 by 200, right? The classic VGA resolution. So if we have a display that has 320 pixels by 200 pixels, our raycaster is going to trace only 320 rays. Remember that we spoke that our raycaster deals with these columns of pixels. So if we're going to cast a ray for each one of the columns of pixels, it makes sense that we only have 320 rays, one for each column of our resolution, right? So this is what raycasting is. In a 320 by 200 display resolution, a raycaster will only trace 320 rays. What does that mean for us? It means that raycasting is usually very fast, right? So we're going to have a very fast rendering because we are only looping 320 times, or how many columns you have in your display. But also, the resulting image is not incredibly realistic, right? Because we are dealing only with the columns, and that is the information that we have, right? We go, we shoot a ray, we get the distance from the wall, and then we render a column of pixels. So the resulting image is not extremely realistic. It is okay for us in terms of gaming, right? So it is a viable option for real-time rendering. When I say real-time rendering, I mean mostly games and quick simulations, right? Visual simulations, things that, when I say real-time is, you move the player to the left, you see the walls in real time rendering to the left. You move the player to the right, you see the rendering to the right. So that is what I call real-time rendering, right? So raycasting, a very good option for real-time rendering. You have historically games getting away with using raycasting in their rendering because we are basically reducing the complexity of the calculations we have to do because we are performing calculations only column by column, right? That is the whole idea. That is a lot faster. It's a lot faster than we compare with the alternative, right? So in the ray tracing world, this is a very classic ray traced image, right? This is an image provided by NVIDIA, a very classic one that you can find online. This is an example of a ray tracing image. In the ray tracing world, the difference is each ray is traced separately. That means that for each point or for each pixel is traced by one single ray. Do you see the difference? Here, each one of the pixels of my image, one by one, I have one ray. So one ray is responsible for only one pixel. That is different than in the raycasting world, right? So up here, we have one ray responsible for an entire column of pixels. That means that for the ray tracing, if we kind of look at the same 320 by 200 display resolution, a ray tracer needs to trace 64,000 rays. One ray per pixel of that image, right? 320 by 200, that is the amount of pixels that I have, 64,000 rays. A lot more rays than our 320, right? What are the implications of that? Slow rendering, right? So ray tracing is a lot slower if I have to render things than simply using raycasting. It also means that the resulting image is extremely realistic, right? So if you have all this granular details, right? Pixel by pixel, I can analyze. I shoot a ray, I can have all these physical simulations of what happens with that ray, right? So what happens with the light if I bounce on that metal sphere? And what happens with the light if it bounces on the wall and then bounces back on the metal? What is the lighting effect? What is the reflection of each one of those materials? What is the refraction element of each one of those materials? Do you see all this physical based rendering? I can simulate these things by using ray tracing, pixel by pixel. That means that the resulting image is extremely realistic, right? We have a slow rendering, but the resulting image is extremely realistic. So unfortunately, as of today, we still don't use ray tracing for real-time rendering. But that doesn't mean that we don't use ray tracing for several other things. If you have to render photorealistic images, or even movies, right? So if you have movies, you have that luxury time to render things for 2 hours, then that is an application of ray tracing. I used to work as a programmer for a company that we used to develop systems for architects, right? This whole 3D visualization of interior design, architect projects. So the customer, they want to see an extremely realistic image of their kitchen, photorealistic image of their room. We use ray tracing there as well. So pixel by pixel, you go and you simulate what happens with the texture of the wood that they want, what happens with the tiles on the wall. So the customer, they want to see this photorealistic image of their project, right? The light bouncing around the room, the reflection on the textures, the wood elements, because let's face it, right? They want to have a preview of how the project is going to look like before they start breaking down the walls and actually creating the project without even understanding what it's going to look like. So for that application, ray tracing was the best option, right? The customer didn't mind having to wait 15 minutes for that whole pixel by pixel ray tracing image, so they really got this photorealistic image. So I just want everyone to be aware that we have these two different things, raycasting and ray tracing. You will see some people say that raycasting is a subset of ray tracing. I kind of agree, right? So raycasting is almost like a ray tracing that is done column by column instead of pixel by pixel. But the fact is, we are going to develop a raycasting engine in our course. Maybe in the future we have a ray tracing engine as well, but for now, just be aware that we are tackling this thing right here, right? We are going to develop a raycasting engine.